Hi guys, today we will speak about modern data platforms. This will be a first video of the discussion about fraud prevention solution, and I think that it will be important to know about some basics and theory which lays behind this solution. In general, the understanding of some aspects which stays behind that will help you understand why some decisions were made this way and not another way. So, continue talking about fraud prevention solution. This is a data-related project. It's intensive for data calculation and data processing. And I will speak about building data platform because this is essential part of the building this solution in general. But the topic of this current session is not about fraud prevention solution. It's about what stays behind or some fundament which lies behind this project. So let's talk about modern data platforms. When you heard about modern data platforms, what do you think about at this moment? Do you think about databases storing huge amount of data? If you're thinking about the second, you're right. If you are thinking only about the first, you are probably 30% right. So today I will tell you about organization of data platforms, some concepts, not all of them. There are a lot of important concepts, and I will try to recommend some aspects of building such data platforms based on my experience of doing that. And the first topic, organization. So when you are thinking about organization of data platform, if you are thinking about keeping data inside of it, you're right. But also there are two other aspects of that. First aspect is how you actually accumulate this data inside data platform. And another aspect, how you provide this data to other external systems. So this is the first concern is ingesting of data to data platform. First of all, we need to accept any data which is coming to our data platform. It's important because there are multiple systems which you are not controlling and they lie behind responsibilities of your team maybe. The data structures and the formats of data which they can provide you are various and you are not controlling them, and the negotiation between teams is very time expensive for that. So you need to accumulate any data which you can gather, and after that you will be able to process it in any format which you will need. While building data platform, you will need to think how to ingest any data to your system, and also you're not controlling the volume which is coming, so you need to be able to store any volume of data in your data platform. So once you will have raw data inside of your data platform, you will need probably ETL services which will transform the data to more prepared formats and will store all this data in format which is prepared for querying. So you will build data warehouses. And at this moment, you are almost ready for using this data for something more sophisticated. Something which is more sophisticated is processing of data. But it's not only processing data, because if you will miss one aspect of that, you will get a swamp of data. I'm talking here about data catalog. If you will not pay attention for structuring of your data, structuring in terms of understanding your data, you will get sooner or later with a swamp of data which you don't know where data set exists and where you can find some data which you need and so on. So data catalog will help you to organize your data logically. Then during processing, you will deal with batch processing and stream processing. Nowadays, people are moving from batch processing to stream processing because it becomes easier now to do that, and you also can get the same result applying stream processing algorithms to data, and you don't need to split this to batch and stream processing. And after that, you can apply also machine learning and some analytics. And you will need to think about how to provide results of processing of your data to other external systems. because in majority of the cases, this data is supposed to be used in some business-oriented applications or end-user-oriented applications. You will need to integrate some streams or maybe some extracts from your data platform, from results, to some external systems. You might need to implement some API, RESTful API, which will be requested for getting data. You might need to implement some streams to enable other applications to automatically react on some events. And you will, of course, deal with some dashboards and reports. And of course, you will need to orchestrate all these three areas. And also, you will need to govern your data. It means that you will need to restrict access to the data. You will need to understand when this data is supposed to be deleted and so on. So it's a kind of providing some policies about accessing, storage, and so on about your data. So all these concerns you will deal with when you will build data platform, data lake, and warehouse. Let's take a look at the very interesting aspect of this organization, processing, because this is the most sophisticated part of the building data platforms. Processing actually has two architectures which are known nowadays. A little bit before, let's say it's old already, we had Lambda architecture for processing of data. And with the time, people saw that they can actually do the same with streaming algorithms, the same, as batch processing. And because of that, they don't really need this batch layer because they can achieve the same with applying stream algorithms to the same bunch of data. And this also simplifies the architecture and simplifies the skill sets which is required for developers who is developing those pipelines and data platforms. Now let's see which technologies you might see in each of those areas. Ingesting, it's anything which actually produces the data, might be the input for your data platform. It might be sensors, databases, files, maybe extracts, or something else, user activity on website, and maybe some streams in Kafka or maybe in another message bus. And then you will need to process it, and there are multiple tools. Some of them are very exciting. For example, Apache Spark is exciting tool actually, and it's worth to learn it. But it's also complicated and sophisticated tool, and you will need to rise the skill set of your developers if you still don't have them. So for example, if you don't have in your company any Java developers, should you go with Apache Spark? It will have a big, quite long learning curve. Probably no. There is other easier technologies which will provide you almost the same flexibility and functionality. For example, DCT, which is streaming SQL language, it will help you to build streaming pipelines and apply very sophisticated patterns, and you will achieve almost the same. Also, Mongo will help you to store unstructured data during you are building your pipeline. So you will be flexible, introducing new fields, new structures, and you won't need to stop your pipelines and so on. There are multiple technologies which are interested on this area, and all of them are worth to learn, but they are also sophisticated. And about serving the data, we will end up with building APIs, streams, and anything you can think of at this area will be related to building regular applications like APIs and maybe some dashboards and maybe applications with which end users will work. For example, you will work with PostgreSQL, which will help you to provide data for some other integrations, or Kafka. If you are building your data platform using cloud technologies, you might be interested in building it using, for example, BigQuery. It allows you to query data which is stored anywhere, in spreadsheets, in files, in databases, just anywhere. And of course, you will need to orchestrate it, everything. And here, Jenkins will help you, of course, and with other CI/CD tools in this area. Apache Beam will help you to orchestrate your pipelines, but it comes with conjunction with Apache Spark and other Apache Foundation tools. Apache Airflow also will help you to orchestrate batch processes and so on. For data catalog, you will need to automatically surf across all your data which you are storing and apply some tags to your data to later be able to request from your data platform what is data set related to, for example, users, for specific users or for something else, and so on. There are multiple automated tools for that, but this is quite sophisticated area. Here, I want to emphasize on one point related to business value and business case. It doesn't matter which technologies you are using, they might be all very interesting, but depending on your business case, you might need very simple technology to solve it. And probably this is the first step which you need to do while doing your data platform. Not go into something very interesting and sophisticated, but solving the problems with what you have, what you know the best. So in other words, technologies solves business problems, and you don't need to apply some technologies just because you like technologies without relationship to business cases actually. Here we came to a topic related to concepts. I gathered some lists of concepts which I thought that will be important, but of course this is not exhaustive list, and if you think that there are some concepts which might be more important, be welcome and add to this list. First concept is about different types of data. First type of data is related to raw data. It's not processed data, not prepared for querying. It's what you are actually storing in your data platform when you are getting it from sourcing systems. Files, maybe some data extracts which are not processed and ready for other queries and so on. Then when you will prepare your data and it will be ready for querying in other algorithms, it will be optimized data and you will store it in warehouse. And analytics data, data which is enriched with additional features, with additional information. Maybe it's already joined with other tables, or maybe it joined with data from other systems. It's ready for showing you some insights, and you are querying that, and this data also clean it for any other times like machine learning. For example, training data sets, it's analytics data also because you already processed it and prepared for specific need. And also it's data which is ready for data scientists to analyze them and for analysts. That is very important concept. For example, you have data for entire year and you will need to check data for previous months only. So you will need to organize your data with these requirements, which will help you to quickly get data which you need. So there is a practice to store incoming data, raw data, according to sources, and data which is used later, it will be stored according to data or according to some other business requirements, depending on how you will query this data. Also, you will need to apply some retention to your data because you will deal with very big amount of data and not always you will need to store all of them. You will segregate your data according to some criteria and you will delete your data because of that. For example, if you don't need your data older than 1 year, you will delete that data. And to help easily do it, you will need to deal with partitions because it will be easier to you to delete one partition which is related to all year, then select data using index across all bunch of data and delete on them, because the second one is more heavier operation compared to deleting only one partition. So you will need to think according to how you will use your data those partitions. And this supposed to be done from almost very beginning. Another aspect is what I've told you already, which is sophisticated even for me, because I'm not using this on daily basis, but it's very interesting, and I think it's worth to invest some time to understand how to apply this technology. When you will deal with a huge amount of data, you will produce huge amount of data from it, and you will need to find this data. So literally, at any moment, you will need to find some specific data set which is related to specific case, and this data catalog will help you to do that. There are multiple multiple tools which will help you to automate this process of auto labeling your data sets and data. And also this data catalog will help you to govern your data. So you will apply restrictions depending on those auto labels, or maybe some other, maybe a manually labeled data, and so on. Here another concept related to throughputs, and it's more related to building of data processing pipelines. During building of pipelines, you will deal with multiple factors which decreases the speed of getting results, literally increasing latency of your pipelines. It might be, for example, slow disk operations. Because of huge amount of data which is coming, your disk might be not capable to store this amount of data in some certain period. Or maybe you are using some not optimized algorithm for computing data, or maybe CPU is not enough. There are multiple aspects which might affect this latency, and you will need to think about that from very beginning. Maybe introducing additional workers which will process data. Maybe changing the storage type to in-memory storage, or maybe something else. It depends, of course, on your requirements and your problems which you are dealing with. And this one may be one of the most important concepts which you will need to think about. But if you are using right technologies, it might not affect you. But still, at some moments, you will still to take care about that. For example, if you are using Kafka, it will solve this problem because it supports this exactly once semantic. But if, for example, you are not using Kafka, or maybe in some other cases when you are transferring data from one pipeline to another pipeline and so on, you will need to deal with this. And you will need to make sure that your operations are idempotent and you are not affecting your data with multiple same operation on the same stuff, because it will introduce some bugs in data, which actually very difficult to debug, because it's not like something not working. You will see that everything is working and you are getting some data, but something not correct. And this is something might be sleeping always from you, like how you will understand that your calculation is wrong if it's calculate, for example, hundreds of factors which are included in this calculation, and so on. So it's very sophisticated, and from the very beginning you will need to make sure that you are supporting this exactly one semantic, your operation are idempotent, and you don't have data bugs. This is very important while you are building data platform. You will spend much more time on bug fixing of data bugs than on bug fixings of some bugs in applications which are visible. And the last but not the least, orchestration of everything. It's important because actually during building of data platform and further, you will deal with multiple components which you will need to deploy, run at some specific schedule, and so on. And doing that manually, it will be very overwhelming work for guys who are supporting that. And you will need to apply some automation for deploying, for running, and so on. Just imagine how much applications you might have. For example, you might have only 20 pipelines for calculation of your data, but this is only processing. You will have, for example, 5 ETL processes, 5 integrations with external data which are sourcing data, and you will have some integrations, for example, 3 integrations with external data which are using results of your pipelines, and so on. This is not very easy to do manually when you will end up with this bunch of different applications. And of course, you will need to deliver that fast, because usually in projects which are related to stream processing, real-time data processing, you will need to deliver everything very fast to production, and this development cycle might be much faster than in regular development. You might need only 1 day for delivering everything, or might be several times a day. And here we're almost done. I will tell you some recommendations which I think might be useful for you if you will try to build data platform or might be working with data processing. So first point, which I think the most important, is think about your business case and don't apply any sophisticated technologies to your project. Believe me, data processing project will be overcomplicated pretty fast when you will start building it. Maybe you don't need this actually. Maybe solving of your business problem needs just using your technologies which you are currently have. And for example, applying machine learning, it's not necessary for your case. And maybe applying some Apache Spark, not necessary for your case, and so on. So thinking about your business case and actual problem which you need to solve. Make sure that raw data is single source of truth in your solution. It's important because at some moment you might end up that you need to stop your pipelines, or maybe some working node failing, breaking, and doesn't produce anything. If you're not storing raw data, you are not able to recover your results. Also, it's very important to have a tool which will help you to query unstructured data. It's important because, for example, you are storing data from multiple external systems and they are providing different structure for almost the same data. For example, you have 3 sourcing external systems which are sourcing user data, and they all have different structure. You need to have possibility to briefly analyze that without yet implementing any pipelines. You just need to see with which data you will work with. And because of that, you will need to query data which is unstructured, literally have different structure. And for example, good tool for that, MongoDB, or maybe others, NoSQL DBs, because there are a lot of external systems which are out of your control. You are not controlling the volume of incoming streams. You can prevent these spikes in incoming volume by introducing throughput thresholds or some throttling of incoming data. But anyway, you will need to think about scaling of your systems. So it's supposed to be deal with incoming stream of data. Also consider high availability cluster. It will be important for you if you will need to maintain it and if you are trying to provide reliable solution for that, and if you want to implement some failover mechanism, you will need to introduce some redundancy to your system to have one passive node which will substitute another node which is failing, for example. And the last but not the least, capture metrics all over your system. It's important to know the latency of your pipelines, the amount of incoming data, the amount even of classes which are created inside of your components, and so on. For example, in fraud prevention solution, we are in Cortex accumulating metrics from very beginning, so we know how many specific data coming to every of our pipelines which we have, what time almost each step is taken, and how many data we are rejecting, accepting, and so on. We have complete overview of what is happening inside of our pipelines and inside of our solution. Using those metrics, you can apply alerts for them to timely react on some problems or some issues if they will appear in your system. That's it for today, and tomorrow, not tomorrow, next time I will speak more about building data processing solution in relationship to fraud prevention solution. And again, we will speak about some concepts and challenges related to that. You will see that when you will dive deeper to such kind of solutions, it will become more and more sophisticated. From one side, it's interesting. From another side, it's very hard. Stay with us.